Hello and welcome back to this latest video in the series of videos. And just before we get into this subject, just want to remind everybody that we do actually have a Facebook channel, NEEC1 on Facebook. You're all welcome to subscribe and join to that, and you can obviously interact and show each other projects, things that you're working on, things that you're repairing right now. We'd love to see what you're actually doing, whether it's just like basic DIY soldering or more advanced project building and design. So everybody's welcome, and it would be nice to see you there, and maybe we can all interact. Okay, with that said, here we are, and today's video is going to be discussing some of the engineering aspects of AI, artificial intelligence. Now, it's all the rage right now, and it's pretty mind-blowing. It's pretty much a game changer as far as I'm concerned, and it's caused a lot of hype, a lot of buzz, and we're just going to explore some simple applications of what can AI do for us as engineers, as software engineers, and I'm super excited to see how that all goes. Okay, so just to get an overall view of the sort of technology that we're talking about and how you can access it. How do we get access to this AI mechanism? So really, it was developed by OpenAI. They produced a front end called ChatGPT, and they've got two versions of going on here on their website. If you go to the OpenAI website, there's a free version of ChatGPT, which uses the OpenAI engine, if you like, and their free version is running on version 3.5. But they'll also do a paid subscription service, which is ChatGPT version 4. Now, version 4 is the model that's only just been released the past few days. So this is all very cutting-edge stuff right now. So to access this, you need to be on the, they call it the Plus subscription, ChatGPT Plus. And that gives you access to version 4.0. But the version 3.5, like I said, is still perfectly fine, and it's completely free to use. There are some speed differences as well. The free version is a little bit slower to access, takes a bit longer to get responses, but the ChatGPT version 4 that they have, the paid version, is apparently much faster and has better access to the service. So that's their own OpenAI version, if you like. They have actually got their own web front end for their service. One thing to remember is it's not actually connected to the internet. So what that means is there is a data cutoff of September 2021. So anything on the internet that happened after September 21 will not actually be in the database for ChatGPT. So it's not aware of anything that happened after that month of that year. You've got to watch out for that. If you're doing searches for things that might not be completely up to date, and it won't look at websites that we have right now on the internet. However, I've just been reading some tweets today, literally right now, and there is talk of plugins coming soon. I believe they're doing it right now, which will allow ChatGPT version 4 to access the internet. So I think they're going to bridge that gap, and it looks like that's going to happen very, very soon, if not already. So we could be looking at internet access for ChatGPT, the paid version, version 4, very soon. Now, the other way you can go here is Microsoft Bing have actually incorporated GPT 4.0 already, and they have been doing it for the last month or two, I believe. People didn't know this, but they've already been using GPT 4.0 for some time already. They just didn't realize and they didn't announce it. Now, one advantage with the Bing version is if you use their Bing search engine on their Bing site, you're getting access to GPT 4.0, which is, as we say, is the latest version. It's free to use, and also it already has connectivity to the internet, with it being a search engine to start off with. So there's quite a lot of interactivity between the GPT 4.0 and the internet happening already. So that's quite a good solution as well. And I've been playing with this with software code and to see whether it can generate software, and it does. It's absolutely fine. So really, you've got a choice of ways to go here. There are probably others, but I'm not going to get into other versions. These seem to be the two main paths to OpenAI right now. For this, we're going to be using ChatGPT. I'll just open this up. Here it is here. And ChatGPT is completely free to use, and you can upgrade. You can upgrade to the Plus version. Costs about $20 a month, and it gives you higher speeds, better access to the network, to the AI engine, if you like. I'm just using the free version here, just so you can see what you can do straight off the bat without paying for it. Quite welcome to upgrade if you wish, and I may well do that myself as I use this more. I'll paste the website in the description, and but I just wanted to pick on a couple of examples and show you what this is really capable of doing on a simplistic level without getting too deep into the whole thing. Now you've got to remember that AI is incredibly complicated. It covers many fields, not just electronics and software. It covers pretty much everything you can imagine, any subject you could imagine. Doesn't have to be engineering, it can be finance, it can be business, it can be designing graphics for a website, you name it, all sorts of things. So we're just going to do a very, if you like, a narrowed down version, and we're going to look at some simple software techniques that we can apply. Once you've actually gone to the website and you've logged in, I do believe you need an OpenAI account to be able to log into this service, but it's free and it's pretty easy to do as well. So once you're actually here, we have an input bar here. Now this is a bit mind-blowing because we're now going to type in a standard, in this particular case English language, but it could be any language you like, I suppose, and this applies to all languages, but you know, here we are, we're going to type something in English. Let's ask it to write us some software. Now this is pretty incredible. So I'm going to type in what they call a prompt, which is a question, if you like, or a request, and they tend to call them, we'll call them prompts. And really the whole thing with AI is to know what question to ask. So if the more detail you put in your question, the better response you will get first time. So let's have a look at this. So let's say, okay, write me some C code to create a binary counter outputting to pins on the, and I'm actually going to use the Arduino Duemilanove board, so I'm going to tell it which board I'm actually using. Duemilanove board. Okay, so write me some C code to create a binary counter outputting to, let's say, all pins on the Arduino Duemilanove board. So you can see what I'm asking it to do. I want it to be a binary counter, and what sort of speed shall we say? How fast is it going to count? With a speed of let's say 10 milliseconds. That'll be 10 milliseconds between each count. Oh, so there you are. That could be a command that you would give to a programmer, to a C designer, and he would go away and he would write that for you. But here we are. There is no C designer. It is AI. So let's ask the AI engine to do just that. Hit return. Sure, it says. There you go. And it's writing us some C code. Now I'm not doing anything here. This is all completely automated. It's off the screen. I'll have to scroll down. And it's telling us also how this bit of code works. And yes, it's understood the 10 milliseconds for the time. So that's pretty cool. But look at this. I mean, isn't that pretty crazy? I've just asked it to write some actual C code and it's done it. Now the question is, does it work? Did it understand what we wanted to do? So I'm going to click copy code. That's now in the clipboard. And I'm going to open up the Arduino IDE. Here we are. Here we are. So what I can do now is paste that code in. This is directly from the AI engine here. Let's see if we can actually compile that and send it to an actual board. And here's the board, and you'll notice I've got like a bunch of LEDs already connected to the output pins. Alright, so we've got like a bunch of pins there. A bunch of LEDs. These are 5-volt LEDs. They don't need any series resistors, just in case you're wondering. I've got them connected to pretty much all of the output pins, not all of the output pins, but most of the output pins on ports. I think it's ports D and ports B on this particular board. The arrangement is port D and B. But never mind, let's not be concerned about that. Hopefully the AI engine can actually sort that out. So what I'm going to do is plug this in, and let's send that AI code to the board. Okay, so now I'm going to compile the code and we're going to upload it to the board and see what it does. So that's now compiling and it's now uploading and it's done. Now then, take a look at that. I'll try and turn it around so you can see it in a sensible. There you go. Look at that. Exactly what we asked for first time, which is pretty incredible because I have been testing this over the last day or two, asking it to do different things, and sometimes it doesn't always get it 100% right. But in this particular case, look at that, it knew exactly what we wanted to do and it's done it. You can see it's counting in binary. It's very, very fast at this end, 10 milliseconds. And this is the MSB, if you like. Yeah, LSB this side, MSB this side, most significant bit. And it's about to go to the end digit there, if you can see that. It hasn't quite got there yet. When this fills up, which is coming up reasonably shortly. Wait for them to all light up. It's coming up. Just hang in there. We'll see. Eventually, we'll see the very end one, the end LED light up. When that goes all on, it's coming up. Okay, here we go. Ready? Boom, there it is. So that's the end one there, and it's counting through again. So we've just created, I don't know how many bits that is. I think it's about 14 or something bits, binary counter, and we didn't write a single line of code. Now that's pretty incredible. So just by typing in a prompt, we were able to, by typing in a prompt, this one here, all I did was say this code here, write me some C code to create a binary counter outputting to all pins on the Arduino Duemilanove board with a speed of 10 milliseconds. Now, I think, well, I hope you appreciate that's pretty crazy. I mean, okay, it's only a simple example. We're not asking it to do anything particularly complicated, but still, look, I mean, it's actually had to work out how to use for loops and the digital write command here, and you know, it already set up the pin mode. It knew how many pins we were going to have to do. It's actually selected up to 14 there, and you know, and it's got a little delay in there for the time that we asked. It did all of that. That's all completely generated by AI. I didn't write anything in here. So let's change this delay just for fun. Let's make it go quicker. So in C terms, you know, we all know you have to dive into here and change the delay, and you can do that because in this particular case it's all very simple. But you know, let's let the AI engine do that. So now I can say, now change the delay to 1 millisecond. Okay, sure, here's the modified code, it says, and it's retyping the code, and I would imagine it'll be exactly the same, only this time. Now it's actually done something a little bit more interesting than just do 1 millisecond. It's using a different function. Now it's actually using the delay microseconds function to give us 1 millisecond. So it did it a slightly different way than I expected. I thought it would have just used the delay and put 1 in for 1 millisecond, but it's decided to switch over to using the microsecond delay. Interesting, but it's the same result. So let's copy that code. Okay, and let's stick that into the IDE. Where are we? Okay, let's delete that last one. Okay, paste that in. No, I'm just doing simple copy and paste here. Simple as that. Control C, Control V. So I'm just pasting the code in, and let's send that to the Arduino board. Okay, now you'll notice it's reset here, and it's uploading the code. And there it goes again. Now this time, it's much faster. I'll just try and get that in focus. Now this time, it's a lot faster, as you can see. And it's really whizzing through the code very quickly now. In fact, you can't even see these significant bits flashing at all. They just look as if they're on permanently, but they are flashing. They're just too fast for the camera frame rate. So that's really getting through. So we've asked the AI engine to change the code for us, to change the speed, and we didn't write a single line of code. So that's pretty crazy. Okay, now then, what if we wanted to do something maybe it's a little bit more complicated? What do you think? So let's give that a try. Okay, right, let's go back to the AI engine here, and I want to ask it to do something very different. Okay, write code in C, and I've got to tell it, well, it probably knows already which board I'm operating with now, so I'm just going to say write code. That's all I'm going to say, write code. I'm going to assume that it knows what we want, C code, and which board that we're now using. Okay, to generate a sine wave, let's say, output at one of the pins at a frequency of, let's say, 100 hertz. Whoops, a daisy, hang on, of 100 hertz. So we're going to make a little signal generator, and it's going to output, hopefully, a sine wave at a frequency of 100 hertz. So off we go. Okay, it's telling us it's going to use pulse width modulation. Yes, well, that makes sense. So we're going to get a PWM signal. Obviously we can't get a pure sine wave output of a pin because they're all digital pins. I don't even think we've got a digital analog converter. We don't have a DAC pin on this particular chip, I don't believe. So it's going to use PWM pulse width modulation techniques to approximate the sine wave. Okay, and here we get a pretty good explanation of how it's going to do it. Fantastic. So it's not just giving us the answer, it's actually giving us an explanation so we can understand the answer, which is very good indeed. So anyway, let's copy that code and we'll put it into the IDE. Okay, so we'll get rid of that last one, and let's Control V, paste that one in, and now it's a little bit easier to read if I sort of zoom in a bit. So all I did was just copy the code from the ChatGPT, and we've just literally dropped it straight into the Arduino IDE to compile. And here we go. So what's it going to do? The sine output pin is assigned to pin 9, so we know which pin it's going to come out of. It's going to send the sine wave to pin 9, and what I'm going to do is in a moment we'll connect that to an oscilloscope and we'll have a look at it. Now I've still got the LEDs connected to the board. You'll see it's still running. It's still running here as a binary counter. It's still going. But what we're going to do is leave those connected just for now. And if this code works, we should actually get like 100 hertz pulsing on one of the pins as it actually outputs a sine wave. That will give us some idea that at least something's happening. Now, what else is it doing here? Output pin. Yeah, so this is just assigning the output pin as an output. Calculate sine wave value for the current time. It's doing a little bit of maths here using floats, and then it's converting it to a PWM duty cycle, and then it's doing an analog write, to a pin. Okay, let's try that then. So I'm going to upload this now, compiling and uploading right now. I want pin 9, and there it is. I'll just hold this up to the camera so you can see it a bit better. Now, a bit better. Now, with the camera you can't really see that that's actually flicking, but if I do that, can you see that strobing? Yeah, so that's a very good sign. It means it's doing something. And what we need to do is now connect that to a scope and have a look and see if it is indeed a sine wave or not. Let's do that right now. Okay, so we've got the oscilloscope connected to the output of the pin 9 on the Arduino, and well, it's doing something, but it's not very good. What we're actually seeing is the PWM waveform, and it is actually approximating a sine wave. It's a little bit difficult to see on this scope. Maybe I should change to the storage scope. We might get a better idea of what's going on. I'll just try that. What we're actually seeing is narrow pulses and wider pulses, and if you were to put that through a low pass filter, you would actually start to see a sine wave. So it's actually doing it. It's a little bit difficult to show right now without putting it through a filter, but I can see by looking at the waveform, hopefully you can see that it's a series of I'll see if I can take a shot there like that. You can see we've got narrow pulses and we've got wider pulses there. We've got wider pulses here, and then it's getting narrower here, and then we're getting very narrow, and then it's getting wider again. So we're getting narrow and wide pulses, which is giving us a sine wave representation. It's probably quite coarse, and it's going to give us a frequency of around about 100. I think it should actually be 100 Hertz. That's what we've asked it to do. So I'm sorry about the glare of the screen here. I've got fluorescent lighting and all sorts in the room here, and it's glaring off the front. I hope you can see that all right. But anyway, that's the point. Now, what I'm wondering is, can we get this any better? So let's go back to the computer and see if we can get AI to actually make that a little bit better for us. Yeah, so let's go back to the chat GPT window, and let's see if we can make some improvements to this. So scroll down. So let's ask it to do it a slightly different way. Let's say make the sine wave more precise, with better resolution. How about that? Okay, let's see what it says to that. Now you'll notice it's actually memorized where it left off, the previous task. It's aware of what we've already said. So okay, let's see what it says. To increase the resolution of the PWM signal by default, the Arduino uses 8-bit resolution for PWM, which means the duty cycle can be set from 0 to 255. To increase the resolution, we can use an analog write resolution function. Okay, so it's going to do it another way, and it's going to modify the code to do that with the frequency of 100 Hertz, and it's going to again put it on pin 9. So we're using the same pin, which is great. Don't have to move my scope probe, but it's going to do it in a different way using the analog write resolution function. Interesting. Now you're watching this in real time, and you can see it's not super fast printing out the answer, and I think that's because I'm just using the free version here. The paid version is probably faster, but it gets there. And to be honest, sometimes I do this, and it's completely fast. It just varies on the time of day and how busy the network is, so results will vary. Let's see what it's doing. Oh, little bit of maths there. Calculate the sine wave value. It's using pi. Okay, which is, yeah, it makes sense, using sine waves. We're making a sine wave PWM. It's the right kind of maths to use. Now it's going to do an analog write again, and it's going to tell us how it works. Okay, so this time it's going to be using 12 bits instead of 8 bits to give us a resolution of 0 to 4095. And yeah, it's anyway, I'm going to stop that, and let's take that code to save a bit of time. Copy the code here, copy code. Let's drop that straight into the IDE. Okay, and we can delete the one we had and post this in. Control V, simple paste. Let's upload that to the Arduino. Now it's got a problem. So it's telling us that it's not declared. There's a function in here, analog write resolution, and it doesn't understand it. Okay, so this isn't actually going to work. Now sometimes this can happen. I'm not exactly certain why, but it's thought the board could do something when it can't, and it looks as if the compiler doesn't like this. So let's ask it to do it a different way. And what I'm going to do is I'm going to tell it that this function is not available. Okay, and we can tell it is not working, and I'll tell it to use the internal PWM counters instead. Okay, now it's going to do it a different way again. And this is what you find. Sometimes you have to, you've got to put it right. If something doesn't work, do it another way. Right, I was kind of hoping it was going to use the internal. Oh, it is. It's using the PWM registers now to do that. The internal PWM. Okay, so let's go and get that code. Same again. And copy that. And let's put that into the Arduino. Clear the last one. Paste in the new one. And go. Now let's see if it can handle that. Okay, it's uploading. So actually that didn't work at all. We've actually got no output whatsoever. So we need to do this a completely different way. I'm not quite sure what the problem is. The output is indeed on pin 9, and it's set to an output. But I've still got the LEDs connected, and I'm not seeing anything at all. So, okay, let's just tell it that it doesn't work. I guess. That did not work. There is no output. Let's see what it says. It apologizes for the confusion. Now it's going to try something else. You'll notice up here it says the Arduino Uno. Now it could be it thinks we've got a different board. So if this version doesn't work, let's try telling it specifically which board we do have. That might make the difference to the to the software. It's possible if it's using the wrong pin or something like that. Now, yeah, this looks different. So this is using fast PWM mode with a top value of 1023, which is a 10-bit resolution. So again, it's using the internal PWM counters, which is great. And it looks like it's going to use some sort of a prescaler as well. Right, okay, cool. Let's get that code and let's give this a try. You'll notice we're still on pin 9 here, so that's good. So again, the scope probe is in the right place. Code copied. Let's go to the IDE and let's stick that in there. That's our code there. Let's tell that to go compile and upload to the board. That's uploading right now. Okay, let's go over to the scope. Something's happening now. I can see the LED flashing, so let's go and have a look at the scope. Alright, as you can see, we've definitely got activity. I'm going to see if I can actually lock this off a bit better, or maybe just take a snapshot. Maybe, hang on. Yeah. Let's make this a little bit slower and take a. Probably should be on DC here, so we're not getting so much curvature at the top and the bottom. And we'll do a snapshot. So let's have a. There, cool. Now, this is way better than what we had before with the previous version. You'll notice we have a very tight PWM here, and which would indicate a high voltage. If you can imagine, all of these pulses are happening very rapidly together, and then you have it slowly they space out. That's the voltage falling to here, which has given us very little output, which is kind of like the bottom of the wave. This has given us a much better PWM representation of a sine wave. And again, what we need to do now is to put that through a low pass filter, something that would give us 100 Hertz, because we've specified the frequency of the sine wave to be 100 Hertz, and we would actually get, I'm pretty sure, quite a decent sine wave output that you could then plug into an audio amplifier, listen to. It would be a 100 Hertz tone generator, if you like. And of course we can change the frequency just by asking AI to change the frequency for us. So yeah, that looks pretty spot on. I'll just see if I can show that a little bit better, and we'll just take a snapshot. Yeah, there you go. So we've got like a voltage there, then we've got like a 0 point, and then we've got voltage there, we've got a sort of a 0 point, then another voltage, either positive, negative, then another 0 point. If we zoom in a bit, you can hopefully see these pulses are slightly wider here than they are here. So this is like a voltage dropping, if you like. If you can imagine, the length of the pulse is actually getting shorter as we go to the right hand side of the screen. So the voltage is actually falling. So that's actually working perfect, and it would just need to go through a low pass filter to turn it into an actual sine wave without any artifacts or anything, and filter out all of the higher harmonics and what have you. So yeah, so I've connected the output of the pin 9 from the Arduino board through a simple CR low pass filter, and as you can see, we're getting a pretty clean sine wave. If I look very closely at the waveform, there is a little bit of stepping, which just sort of means that I haven't got the component values for the CR network exactly right, but it's pretty damn close, and you can see there's our sine wave. And all I'm doing is I've got a little filter. All I'm doing is I've got like a little filter network here. It's just a simple electrolytic capacitor and a resistor, a little CR low pass filter, and the output pin 9 is going straight to that, and then the scope is coming from that. So it's very simple, and that's given us the sine wave output. Now, one thing I have noticed with this is the frequency appears to be wrong. My scope is telling me that this is 30 Hertz when we actually asked for 100 Hertz. So there's a problem with the frequency, and what I can do is I can verify that. Take the scope probe and put it into the frequency counter, and I don't know if you can actually see that or not on the top, but it's given us 30.1, 30.2 hertz, and I've got a feeling it's something to do with the interrupts going on within the chip. Would probably have to be a bit more specific with the prompt that we're using to tell it to maybe disable the interrupts, or tell it that there's a problem with the accuracy, and see if we can actually make it more accurate. So yeah, but to be honest, that's about as far as I'm going to go with this. And the main thing is that, you know, we do actually have a working piece of code, even if the frequency's not quite right, you know, but we do actually have a sine wave, and we didn't write a single line of C code. Alright, so I've asked the AI to change the frequency to check its calculations in a new prompt. I told it that the frequency was incorrect, and it's come back with a new piece of code, and it's done it. So now, I don't know if you can see this okay, but we're at 100 Hertz. It's bobbing about a little bit. It's not completely accurate because of the way that the Arduino's approximating the sine wave. There's a certain amount of resolution error, so we've got a little bit of jitter going on, but I hope you can see that is actually 100 Hertz, 100.1, 100.2, that sort of thing. And if we look at the scope, I'll just change the inputs over to the scope. And let's have a look. There's our sine wave, and you can see the jitter. It's moving around a little bit. And what I also did was I told it to reduce the precision, so it's gone down from a 10-bit resolution down to an 8-bit. So there's a little bit of stepping going on in there as well. But I hope you can see that the process of asking AI using an appropriate prompt, or a request if you like, and asking it to produce a sine wave at one of its pins on the Arduino at 100 Hertz, and it's done it. And I didn't write any code. So really, as far as I'm concerned, from an engineering standpoint, even with this very simple demonstration, I hope you can see that AI is pretty much going to be a game changer here. I believe the hype. It can write code that actually works. Now, I could have wrote this myself. You know, if you're a decent software engineer, if you're competent, you could probably write this within half an hour or something, or an hour. But that's time saved, and you can actually do, you know, spend your time on other things more important, like the overall project. And you know, normally projects would be far more complicated than this, and this could just be one module of many. So I hope you can see that. Well, I don't want to say it, but it could actually put people out of work. That's the flip side of AI. Now, the way I look at this is not to be frightened or anything like that about it. If you're a software designer, software engineer, and you're looking at this for the first time, you'd be thinking, oh my god, I'm out of a job here. It's not really, but I do think what we have to do, this is my opinion, mind, I do think what we have to do is embrace AI as a new super tool, as I call it. It's a bit like having a really good assistant by you at all times. If you've got any questions, if you need any code written as a module, you can ask the AI to give you a hand, and it will actually produce code that functions, as you can see. So to me, it's a superb tool. It's a superb assistant to have by your side, and you can talk to it just like talking to a person, and it's able to produce code to help you do your job. It's not a replacement. At least I don't see it as a replacement. I don't fear this. I actually embrace it, and I think it's fantastic. So now, no matter what field you're in, not just electronics or software, and you know, whether you're in the artistic, creative side of things as well, I would just be embracing this as a new tool. and learn it. Put it on your CV, put it in your skill set, whatever. And you know, if you can write the correct prompt, if you can actually think of what the question needs to be, which is the important thing with AI, is asking the correct detailed question. If you learn how to do that properly, you'll always get back a decent answer, something that you can actually work with, and it can save you an awful lot of effort and time. Now, it's not perfect, obviously, and I've had to change the prompt about 3 times so far to get it to this point that the code is doing pretty much what I want it to do. If you remember, at first the resolution wasn't very good, so we upped the resolution, and then we got a better quality sine wave, and then we noticed that the frequency was incorrect. It was about 30 Hertz instead of 100 Hertz, so then we had to do another prompt to change that. Now I could go one step further and say, okay, everything's correct, now just increase the resolution back to 10-bit precision, and it would no doubt do that, and hopefully it wouldn't break the frequency of 100 Hertz, which is what we've asked it to do. Of course, the frequency could be anything you like, up to the limitation of the hardware. 100 Hertz just seems like I don't know, just feels like about a sort of a nice easy figure for the hardware to handle. It could probably go a lot higher than that, I believe. But then, of course, the higher you go, you start to hit the limitations of the clock speed of the processor, and you will get artifacts, probably more jitter, etc. So this is a decent little way to look at it. And of course, the output's not perfect here. You can see it jiggering around, but it is 100 Hertz. It's telling me here it's actually 100 Hertz as well on the scope. So you know, plus or minus probably 1 or 2%. So it's doing the job. So AI is definitely here to stay. You can't uninvent it. So I certainly wouldn't feel threatened by it. It's a fantastic tool, and that just saved me probably an hour's worth of figuring out how to. Maybe it's even longer if maybe you can't program at all, and you don't know how to program in C at all, and boom, there you are. You've got an assistant that can write code for you. I mean, how about that? It really is a game changer in my mind. This is going to change the industry. It's going to revolutionize the industry. I can just completely see that now, just with these simple tests, you know, loading in a prompt and coming back with the actual runnable C source code that you can put into your target device. It's crazy. Really, it's actually crazy. And of course it applies to lots of other fields, like I said earlier. It's not just software. I can see this being used in PCB design very soon. They're already talking about a plugin for well, there's a community which are talking about automatic component placement. So when you come to design your PCB, you can really get best use of your real estate on the board without any gaps and, you know, any unwasted sort of copper area, and it will know where components like chips and other components, the best position to put them in. At the moment you can't do that. It's down to a human to decide where to put the parts, but I can really see that coming very soon, and AI is going to help us with that too, with PCB design. It's going to come into all sorts of engineering fields. It's pretty crazy. So with that, I hope you've gained something from this video. But anyway, please do check it out, and like I say, I don't think it's something to be feared. I think it's something to be embraced. This is all changing the industry as we speak, and reading some of the forums in the chat rooms, the rate at which this is accelerating. New products are coming out all the time. It's very difficult to keep up. To be honest, it's happening so quick. New apps being written, everything, and it's just snowballing. So better get on that train. That's what I would suggest. Okay, I'm going to leave it there, and thanks very much for watching, and here's to the next time, and enjoy your AI.